Today we're going to be taking notes for our first lesson in our geometry unit, which is about quadrilaterals. So there's a lot of different types of quadrilaterals we're going to be learning about, and they all talk about different vocabulary words. So let's go over those vocabulary pieces first. So first, a right angle. Remember, a right angle is an angle that measures exactly 90 degrees. And we use a symbol of a little box in that angle. So go ahead and draw that box in yours as well. Now, congruent means that they are equal. And the symbol that we can use to show that two lines have the equal length is a little, like a tally mark right in the middle there. So you'll notice that my two that are on the left have a single tally mark, and the two on the right have two tally marks. So that means that the two that have the same number, so this one right here and this one right here, have equal measure. And these two have equal measure, but this one in the middle does not have the same measure as the one with two. So they match the one with the same number of marks in it. So now let's go ahead and talk about parallel. Parallel means that those two lines will never cross. The symbol that we use for parallel looks like a little arrow in the middle of that line. So I'm going to use a single arrow for these two on the left and a double arrow for the two on the right. And just like with congruent, if they have the same number, that means that they go together. Our next vocabulary word is perpendicular. Perpendicular means that those two lines meet at 90 degrees. And kind of like our our right angle that we talked about first, we're going to use little boxes there. So because I have two little boxes, that means that those two lines are perpendicular. They meet at 90 degrees. And our last new vocabulary word that we're going to talk about is bisecting. If something is bisected, it is cut in half. So if two lines bisect each other, that means that the part on the left is an equal measure to that part of the line on the right. And that also means that the part on top is equal measure to the part on the bottom. So remember, if it's the same number of marks, that means that those two pieces go together. All right, let's talk about our first quadrilateral, and that is just a plain old quadrilateral. So when I say that a shape is a quadrilateral, that means it has four sides and that it is a closed figure. So when I say closed, that means that it can't be open. It has to be a complete closed shape. One property of a quadrilateral is that interior angles add up to 360 degrees. And that's just a property that you need to memorize. Quadrilaterals have all those angles on the inside, add up to 360. And I have two drawings of quadrilaterals. So sometimes they look weird and sometimes they look like shapes we've seen before. But if it's got four sides and it is closed, it is called a quadrilateral. Let's talk about trapezoids now. So trapezoids are a special type of quadrilateral. They have exactly one pair of parallel sides. Remember, our symbol for parallel are those little arrows. So let's go ahead and draw a parallel symbol on the one on top and the one on the bottom. And let's go ahead and do it for the other shape as well. Let's mark the sides that are parallel. Remember, parallel lines, you have to think about them being extending. So if I look at this one on the left and this one on the right, if I extend those lines, and I'm going to do it real quick just to show you, if I extend those lines, they would end up meeting. So I can't mark that those two are parallel. But the one on the top and the one on the bottom, that does work for being parallel. All right. Another property of a trapezoid is that parallel sides are called bases. So those two sides that we marked, those could be marked as bases. So I'm just going to go ahead and label this on the top of that shape on the left. That's a base, and on the bottom is a base. So if I ever talk about the bases of a trapezoid, that's what I'm talking about. Now let's talk about the non-parallel sides. So those ones that we said were not parallel, they are called legs of a trapezoid. And it seems kind of silly, but that's what they're called. So the legs are the ones that would run into each other if I kept drawing that line. All right, next up we have our isosceles trapezoid. And if you remember from a couple of years ago when you learned about different types of triangles, we had something called an isosceles triangle. And it kind of goes together. So think back, we're going to go over what that means. So an isosceles trapezoid is a special type of quadrilateral and a special type of trapezoid. So that means that it has four sides, it is closed, and it has everything that talked about for trapezoid. So something that's special for just isosceles trapezoids, though, is that they have legs of equal length. So let's go ahead and mark that on, use our symbol. So remember, equal length, we can talk about them being congruent. So I can put a little tally mark through those two that are congruent. And then let's talk about those base angles. So it also has congruent base angles. So I'm going to go ahead and write that word in here. You got to kind of write very small. And actually, this is a symbol that we didn't really talk about up top, but just like how we put those lines through the sides that are congruent, we can also make a line in the angles that are congruent. So if they have one angle or one line through the angle, that means that those two are equal to each other. And also the ones up top are equal. So I can use two lines to show that those two are equal to each other. And the last property of isosceles trapezoid is that it has one line of symmetry. So go ahead and put a 1 in that little blank. And then let's go ahead and mark a line. So a line of symmetry means that it's exactly the same on both sides. It's almost like you can fold it in half and it would match up exactly. So that's our one line of symmetry on an isosceles trapezoid. And that's special for just isosceles trapezoids. All right, we're going to switch gears a little bit away from trapezoids and start talking about some parallelograms. So a parallelogram is a special type of quadrilateral, and it has two pairs of parallel sides. So let's go ahead and mark that with the little arrows. So the one on the left and right, I'm going to use one arrow to show that those two are parallel to each other. And the one on the top and the bottom, I'm going to use two arrows to show that they are parallel to each other. Another property of a parallelogram is that it also has two pairs of congruent sides. So I'm going to use one little tally mark through the left and the right, and two little tally marks for the top and the bottom. So those sides are both congruent and parallel to each other, and that's what makes it a parallelogram. So our next quadrilateral we're going to talk about is a rectangle. Now a rectangle is a special type of quadrilateral, but it is also a parallelogram. The thing that makes a rectangle special, though, is that it has four right angles. And remember, our symbol for right angles are those little boxes in the corners. So we need to go ahead and draw those boxes in the corners of all of those angles. And that's what makes it a rectangle. All right, next up is a rhombus. So a rhombus is a special type of quadrilateral and parallelogram. But what makes a rhombus special is that all four sides are congruent. So if you take a look at our picture here, the little one up top, I'm going to go ahead and make a little mark. So I'm going to put one mark in all four sides because all four are congruent. Opposite sides are also parallel to each other, just like a parallelogram. The opposite angles are congruent, and we already have those symbols written in there. And then the other thing that this other picture here we have to mark is that diagonals both bisect each other at right angles. So let's go ahead and fill out our lines that we have here. So parallel, congruent, and then diagonals bisect each other at right angles. So I needed one more word written in that blank there, right. So where I just put all of those little boxes in the middle, remember that means that they make right angles, but now I'm going to mark that they also bisect each other. So I'm going to put one mark through the one that's, yep, right there, and then one mark on the other, and then the other two are going to get two marks. So remember, the one that has one mark right here is not equal to the one that has two marks. you have to count to know which ones go together. So these two that have only one mark are equal to each other. These two that have two marks are equal to each other. But all four of these angles in the middle are right angles. All right, next up is a square. So square, even though it seems like a really simple shape, it has a lot going on. So it is a special type of quadrilateral, parallelogram, rectangle, and rhombus. So it is all four of those shapes, but it also has special things about it. So all four sides are congruent. So I'm going to go ahead and make a little tally mark in all four sides of this shape on the left. All four angles are also right. Which is 90 degrees, and I can put those little boxes to show that those angles are right. And then our last quality of a square is that it has four lines of symmetry. So let's go ahead and mark our lines of symmetry on this other shape that we haven't marked on yet. So if I go straight down the middle, that's our first line of symmetry. And also if I go straight across, that's another line of symmetry. And then our diagonals are also lines of symmetry. So both diagonals there. So if I have a piece of paper that's a square, I can fold it four different ways to fold it perfectly in half. So those are four lines of symmetry. So that concludes our notes. Make sure that you have all those symbols we wrote in there because every single one is very important when we talk about quadrilaterals. And next we're going to be talking about how we can sort these into different groups.